Okay, let's find the formula for this polynomial. We're given that it has to be degree 3. We're going to get real coefficients, and in the end, we're going to expand this all the way out so that we can see the actual polynomial. We have a complex 0 here, 2 plus 5i. We have a nice real 0 here with negative 8. And we're given the y-intercept to go along with this as well. All right, so some things to note on this. We have one complex 0. The complex, we also get its complex conjugate is also going to be a 0. So let's go ahead and list these out. We have negative 8 as one of our zeros. 2 plus 5i is a 0. We also are going to have 2 minus 5i because complex zeros come in pairs. So they're conjugates, meaning you simply have to switch the sign in the middle between the two terms. Is going to switch. That's going to be its conjugate. It also goes as a 0. All right, from here, let's go ahead and set up some factors to go along with it. These are our zeros. So factors always go as x minus whatever the 0 is. So in our case, our factors are going to be x minus negative 8 is x plus 8. We have x minus 2 plus 5i. We have x minus 2 minus 5i. I'm also going to go ahead and put an a out here in front. That a is going to represent some sort of scalar multiple, and we're going to have to find that at some point. That'll be towards the very end. I'll warn you that most of this problem really just relies on our ability to distribute and keep track of terms, combine some like terms together. It's really not that bad overall, but you just kind of have to be careful. So I'm going to begin by first distributing on the inside of our parentheses. Each one of those has a negative in front of the inner set of parentheses. So it's going to be x minus 2 minus 5i. And then we get x minus 2 plus 5i. All right, from here, let's go ahead and continue on our distributing journey. I'm bringing along the x plus 8, that factor, and the a. Let's focus on what's on the inside here. I'm first going to distribute this x to each one of the terms in the second set of parentheses. So that x times x makes x squared. X times negative 2 is negative 2x. X times positive 5i is positive 5ix. Next, I'm going to move on to this negative 2. It gets distributed to each one of those terms. So we get negative 2x. Negative 2 times negative 2 makes positive 4. Negative 2 times positive 5i is negative 10i. All right, lastly, we have to move on to this negative 5i. Distribute that to each of those terms in that last set of parentheses. Negative 5i times x is negative 5ix. Negative 5i times negative 2 makes positive 10i. And negative 5i times positive 5i is negative 25i squared. All right, closing off my parentheses there. It looks kind of messy at the end, but that's just a set of parentheses. From here, let's go ahead and say we've got a few like terms. So let's try to combine whatever we can, clean this up a little bit. We have a positive 5ix. We have a negative 5ix. Those combine to make 0 ix's. What else do we have in common? We have a negative 10i and a positive 10i. So those will go ahead and combine together. Let's move down to our next line. We have a, the x plus 8 can come along. We're still left with x squared. We have negative 2x minus 2 more x's will make negative 4x's. Constants, we have that plus 4 can come along. We also have this minus 25. Instead of an I squared, I'm going to replace that with a negative 1. Okay, from here, let's go ahead and say the a is going to come along. X plus 8 comes along. X squared minus 4x. And then our constants can combine together here. I'm going to think of this as 4 plus 25 is going to make positive 29. All right, next, more distributing, right? This x is going to get distributed to each term in that second set of parentheses. So the a is going to come along. We're going to go x times x squared is x cubed. X times negative 4x is negative 4x squared. And x times 29 is 29x. All right, moving on to this positive 8 gets distributed. That positive 8 is going to give us 8 times x squared is 8x squared. 8 times negative 4x is negative 32x. And 8 times 29, break out the calculators on this one, right, is positive 232. Again, we have a few like terms. We can go ahead and combine these together. The a is going to come along. X cubed comes along. We have negative 4x squareds plus 8x squareds makes positive 4x squareds. We have some x to the first power terms. We have 29x minus 32x's is what? Negative 3x's. And then our constant, the plus 232, can come along. All right, at this point, we can go ahead and put our p of x on the other side. Let's take into account we haven't used our y-intercept. All right, now we can definitely go ahead and distribute our a to each one of these terms. I'm going to wait on that just a second. Let's go ahead and use our y-intercept that was given to be 0, negative 464. See how that can be used. Okay, so what this tells us is negative 464 is a value for our entire function, the p of x part, where 0 is a value for x. So let's go ahead and fill this in. We're going to get 0 cubed plus 4 times 0 squared minus 3 times 0 plus 232. This is going to simplify down pretty nicely for us, where we get some zeros added and we get 232 overall on the inside here. To get a, we're simply going to divide both sides by 232. We're going to find that our value for a is going to be negative 2. That worked out pretty nicely. All right, what I'm going to do with this value for a is I'm going to go ahead and put it back in up here where we had almost had it complete. All right, so final answer here is going to be p of x is going to be negative 2 gets plugged in for the a. Then our x cubed plus 4x squared minus 3x plus 232 comes along. Last step here is we're going to go ahead and distribute that negative 2 and say our final answer is negative 2x cubed minus 8x squared plus 6x minus 464. All right, so there we have it. Our polynomial, third degree, as we can see, highest power on x. It's going to have those both complex zeros and that real 0 at negative 8. And it's going to have that y-intercept at negative 464. So I hope this helps out. I know this is kind of a pain of a problem where you have to multiply it all the way out. Just be careful as you're doing it, and you'll get to the right answer.